arts. He's based at the University of Arts in London, and looking at kind of scene perception, and so he does kind of visual cognition on film. So he does lots of very high tech ways of looking at things, and they're actually doing. We went over and had a meeting with them recently. They're doing a project trying to use generative AI to reproduce video content that minimizes executive function deficits in children when they're watching them, basically. Because there's quite a lot of evidence. Well, they've done some papers that you get these short-term deficits in executive functions following short bursts of TV, and they're trying to work out what is it that's causing that, which is exactly what you were emailing about this morning, Emily Greenwood, or I saw an email about that following Martha's presentation last week. And we think it's to do with arousal. Our explanation is a little bit different to yours. So maybe we can talk about that at the end if we've got time, Emily. Okay, but this is kind of based on this idea that, I forgot about this, but do we, how do I do this? Sorry, let me just unscrew that. This is actually quite relevant. So I don't know, is it easy for me, because I've got decent internet now, so I was going to get everyone to watch it at home.
Audio has a new feature that just...
Can you hear that? Yeah, okay. Well, I might as well just play it here then. Obviously, we don't need to watch the advert. This is like a 3-minute clip. It's a very, very famous, one of the most famous opening shots from a movie, Touch of Evil, Orson Welles.
Blew my mind. You can take a link from a YouTube video and plug it into their new Link Match AI.
Okay. So this is about, I won't let it watch the whole time. In fact, I will let it watch. We'll just watch this together, 4 minutes, okay?
You folks are American citizens?
I am, yes.
Where were you born, miss?
Mrs.
What?
Philadelphia.
The name is Vargas. Hey, Jim, you see who's here? Sure, Mr. Vargas. Out on the trail of another dope ring?
On the trail of a chocolate soda for my wife.
Your wife?
Jelly, you're right, officer.
Hey, can I get through? A lot of talk up here about how you cracked that Grandy business.
Yeah,
What?
I hear you caught the big boss. Only one of them. The Grandys are a big family. Good night.
No purchases, Mr. Lineker.
Hey, I got
You're an American citizen, miss.
I got the ticking noise.
Yeah, okay.
No, really, the
Good night.
ticking noise in my head.
Mike, do you realize this is the very first time we've been together in my country?
Do you realize I haven't kissed you in over an hour?
Okay, the only bit that comes up is some very sexist after that. Don't worry, darling. I'll deal with this as he sends his wife back in. So obviously there's a lot of interesting things to say about that. And if you study film studies, that's the type of thing you sit and write long essays on, because it's a very, very rich, complex piece of 3 minutes of cinema. But the thing that they're interested in is the moment where you can see from these screen grabs, the moment where Vargas is walking, yeah, and they're tracking people's eyes as they're looking, and they find a blob of gaze fixations on the boot of the car that you've just seen the bomb being put into, yeah. Here in particular, you get it. So this is him walking down the street, and that's the car, and then you get a blob of gaze. The biggest blob is on their face, yeah, and then you get a smaller blob on the boot of the car, yeah. And then when you do this as a slideshow, so you show a series of static images of the where people are looking out of context, and you don't get that blob, yeah. And if you show it dynamically in context when you've seen what's been happening before, then you do, yeah. So this is, you know, they use it as an example in the paper of the types of things that are hard to explain when you're looking at kind of, this is all within the world of eye movements during kind of TV viewing, yeah. The goal is to discuss our understanding of events as they unfold over time, influences our attention selection, yeah. So basically, the structure of the paper is the easy to explain stuff about explaining kind of eye movements in a naturalistic scene, yeah, which is all about kind of salience and prior knowledge and task demands and that type of stuff. And then how do we integrate that with this higher or harder to explain stuff, which is all about, you know, how we understand kind of narrative events in their complexity, yeah. It's a particularly interesting kind of example, that Touch of Evil, because it's shot in one take, obviously, and there's lots of things going in and out of sight. So it breaks a lot of the rules about, you know, how we construct kind of narrative events. It's purposely trying to, you know, discombobulate you and get you into this kind of, I don't quite know what's going on. This is, you know, confusing, and to get you to draw in. So it does it in a very, you know, skillful way, to the point of making this process is hard, yeah. But we're not worrying so much about that. We're just thinking about how does the fact that, you know, I'm watching this scene unfold, I've just seen someone place a bomb in the boot of a car, and then I've seen these other series of events. How does that then influence my behavior as I'm watching this scene unfold, yeah? So this is what Tom Northrop has just written a paper on, looking at how children learn to construct kind of narrative events. How do they learn to carve nature at the joint? So how do they learn to identify discrete kind of series of events in a continuous experience of reality, yeah? So that's the other reason why I thought it might be interesting to look at. Yeah? Make sense? Yeah, okay.
Oh, sorry.
Yeah, Tom?
Sorry, Sam, I'm just, this is quick, but if we're interested in reading now as a lab, I can think of several books that use the same, or piece of literature that use the same technique. And I don't know how we would possibly measure stuff like this in a literary sense, but just to say that I think that's possible. Well,
what
sorry.
do you mean they use the same idea?
Well, I guess I'm thinking, just because I just finished reading the book Neuromancer, like the action is very rapid, and there are a lot of terms which the author has obviously thought through, but are introduced for new objects in the world that the reader won't have encountered. And so the overall effect is this sort of, you're being carried along with events in the same way that scene was sort of carrying you through in one take, and you have to kind of absorb what you can and accept that you're sort of confused. But then also things like William Burroughs, who would physically cut up his novels and throw them in the air and piece them back together. This sort of carrying you along with events, but kind of taking you off guard as well with the narrative technique.
Yeah. The first ones, isn't there some narrative irony or something? There's some word for it. I remember doing that when I did the O-level English. I can't remember. So, man, were you going to say something?
I just kind of related to that like I'm just saying like that there are some studies about event segmentation in reading, which is actually in a way it's actually easier to measure like segmentation in reading, because like segmentation is kind of quite well represented in the structure of language itself, like in syntax. So it's like, yeah, it wasn't like completely related to what Tom was saying, but just saying there is like studies of how, you know, like, yeah, when we do like film and stuff, we have to interpret when boundaries are and use different methods to find boundaries. But in like segmentation actually is a bit easier to study in reading, like written narratives in some way.
Yeah, Pierre, are you there? Where are you? Are you in the silhouette?
Yeah.
Have you read that paper that I sent you by Nate Cohen?
Yes.
That's on hierarchical structures in narrative events.
Yes.
Yeah,
And they're using like setup, events, follow-up, kind of big structure where they're classing events in a cartoon, so like in a comic strip cartoon. Are they like, yeah, winding up the action, doing the action, or seeing the consequence of the action, and they're saying that this is like a tree shape. I think that's what their point is.
Yeah, maybe we'll get to that when we get to the narrative events. Yeah. Okay, so we start with what we know already. Yeah. So this is a paper that when I was working with Tim, this was 2010. They did this. So this is, you know, the first thing that everyone knows about kind of things before we get onto this harder things about kind of how we construct and track narrative events. Yeah. These are like really basic things, different ways that we can predict where people are going to look when they're viewing, you know, a scene unfold in front of them. Yeah. So the first thing is the easiest thing, which is just you take a large bunch of different types of video from Charlie Bit My Finger through to BBC4 clips and that type of stuff. Yeah. And you get adults to watch, you know, an hour's worth of telly, and then you just deconstruct it for these different feature dimensions. Yeah. Luminance, red, green, blue, yellow, edges. And this is kind of another way of doing edges, basically. I don't know what Harris corners are, and flicker is just the change in luminance between frames. Yeah? So you just calculate one frame, you calculate the next, you calculate the luminance of each, and you just subtract it. Yeah, and then optic flow is so if you do that, just the edges of the object that's moving show up because they're the bits that are changing in luminance a lot. Yeah, but then optic flow is a cleverer way of doing it, where you actually get the whole object that's moving shows up. So which object is moving from one to the next. Yeah. And then you just do an ROC curve to see which one of these is predictive of where people are going to look. And you find that they're all predictive. Luminance is slightly predictive, red, green is slightly predictive, blue, yellow is slightly predictive. But then these movement ones are much more predictive. Yeah. So flicker and optic flow are most predictive. Yeah. So that is the first thing that we know predicts kind of where we look when we're watching scenes, yeah? And nobody's really done this with kind of babies to find out what they know is salient, but they know that, you know, this, if you apply these adult kind of salience metrics, then they do significantly predict kind of looking behavior in very small people. But yeah, we think probably salience works kind of in a slightly different way. Yeah. And this is just, you know, when I'm presenting this to early years, invite people, you know, Gemma and I do lots of stuff on, you know, designing early year settings to minimize kind of attention clutter and to help, you know, children to pay attention in a kind of messy, busy place. Then I always say this is probably like just an evolutionary thing that, you know, for most of our life's been pretty dangerous. And if there's movement anywhere on our visual field, you know, our attention automatically gets drawn to it. So there's lots and lots of research, and this is a kind of a pre-attentive mechanism. Yeah. So that's the first thing. Obviously, it gets a lot more complicated than that. Anyone got anything they want to say on that, or crack on? Crack on. Okay. So that's the first thing, and then we've also known from back to Jarbus in the 1960s, and I can't remember. He had a really cool, really homemade way of actually tracking this. Not Charles Bronson. He was a mass murderer. Someone Bronson came up with another way where he shone a light onto a baby's eyes, also in the 70s, and then reflects it onto the back wall of his garage. So he made the whole eye movement, and then he traced it to look at baby's eye movements. But from a visual cognition point of view, the very important finding from Jarbus is that it's not just about what's salient. If you give people, in this case, he was giving them Victorian watercolors to look at, and you ask them to estimate the material circumstances of the family versus give the ages of the people. Versus surmise what the family had been doing before the arrival of the unexpected visitor, and so on and so on, then that changes their gaze behavior. Yeah. So they look in different places depending on what task you've given them to do before. Yeah. So that told us this other very basic thing, which is not just about what an outside world is drawing our attention towards it. Yeah. It's also to do with, what am I trying to find out? What are my goals to try to find out from the scene? Yeah. So that's the second kind of basic thing. And then another kind of thing, which is kind of they characterize in this paper as top-down influences, but a different type of top-down influence. This is knowledge-driven, yeah? Is shown nicely from this paper, which was John Henderson, who's done a lot of this type of work up in Edinburgh. And what he did was he just got a real-world scene. This was Amazon Turk. This is the type of thing you can do with Amazon Turk very well. He just cut that visual scene into lots and lots of different circles, yeah, either at 3 degrees, so really small circles, and larger degrees, 7 circles, and then just got them to rate. I can't remember exactly what the question was, but it was something like, is there something meaningful within this circle? Yeah. So for example, here and here would be examples of something where there is something meaningful within that circle, and here is something not meaningful. Yeah. And he found that the location of this, is there something meaningful within this circle, yeah, is very predictive of gaze location when they're looking at static pictures. Yeah. So this is a different type of influence on gaze behavior that isn't either salience, they checked, and it's not just salience. Yeah. So it's not just salience, and it's not just what are my aims in viewing this scene. Yeah. Because in this experiment, they didn't give people an aim. Yeah. So this is another type of top-down influence, which they call kind of knowledge-driven. Yeah. And other ways of looking at that, Eckstein found that when searching for chimneys, viewers first occasionally went to locations and scenes where chimneys were expected to be. Yeah. This is evidence that a schema, i.e. knowledge that houses of chimneys that tend to be found on roofs, influences attention selection, i.e. choosing where to send a cicada. Yeah. Make sense? Yeah.
I have a question.
Yeah.
So are we seeing all those 3 perspectives as independent of each other? Because I would assume that something that's visually salient is something that we have knowledge over, and then it's probably associated with something that we want to do. So I see overlap on.
Yeah, so they do check that it's not just that, but I'll get to a bit later on where they talk about like a hierarchy of influences. So having identified these types of influence, as well as the harder stuff that they're going to get onto, which is how does my dynamic understanding of an evolving scene, how does that influence my gaze behavior? Then there's a bit in the paper where they talk about, okay, which of these is most important? Yeah, if I put 2, if I have, for example, you could imagine where, there's a knowledge-driven stuff that's not salient. Yeah. So a dark trunk in a thing is not particularly salient, but I know that it's something that's important and meaningful. So when you do find relatively rare incidences where the 2 are not overlapping, yeah, you can say which is more important. Yeah. But generally, you're absolutely right. Things that are more salient also tend to be, more knowledge-driven. Yeah. So for example, faces are very salient, but it's also a lot of knowledge-driven kind of thing that salient faces are important to look at. So generally there's a lot of overlap, but if with enough data you can tease them apart. Yeah.
Sam.
Yeah.
I was just wondering if they controlled for centering in this, because that also might interact with those
Yeah,
things,
so that's
especially the
another-
meaning one.
Yeah, they don't actually talk about that much in this paper, but so one other person who's done quite a lot of work on this, I examined his Viva, is Dan van Rensruder, and his supervisor at Amsterdam, who I went to a talk of his last week, but his name escapes me now. And they talk a lot about this eye centering. Yeah. So if you show them pictures on a frame, then they tend to look in the middle of the picture. Yeah. And it's actually exactly the same in real world, 3D worlds. Yeah. So that's why doing what we do, which is just having a little camera, which is here, as opposed to a little boom, which lets you look at where the eye is looking within the visual field, doesn't actually make that much difference, because we tend to, what we do is we move our eyes and then we move our heads. But then for a long period of time, we tend to keep our gaze focused relatively in the middle of our visual fields. Yeah. So that's why we move our heads. We could, if you think about it, you could just do a lot of moving just by moving your eyes around while keeping your head still. But we don't tend to do that. We tend to center our gaze within our head orientation as well. Which is why when you're doing this type of experiment, which is just showing people pictures on an eye tracker, you get a very large cluster around the middle of the screen. But yeah, it's not particularly cognitively interesting. That it's more interesting from the moving around a dynamic 3D space, right, Tom?
Yeah, I mean, the reason I think it's interesting here is because it's where if it's like a photo that someone's taken, they're more likely to put something meaningful in the center of a photo rather than like a salient object in the middle of a photo. I mean, like unless their objective was to take a photo of the most salient object in the room, but if it was just to take a photo of something, then it's more likely that you're going to get meaning closer to the center than, and like the centering thing is something that also we, learn to do because we expect something to be in the middle. So I think that's the only reason I say it, is because it could confound like the differences between salient and the knowledge driven.
Yeah, that's a good point. Yeah. I think they try not to have like Instagram snaps. They tend to do like, I don't know how they do it, but yeah, it's a good point. Yeah. Okay. And then basically, I mean, this is kind of goes to Calliope's question. So basically, and then these are all people like Itti and Baldi have done lots of stuff about how you can decompose an input image into these kind of different types of feature maps. Yeah. So one is expectations, one is behavioral goals, one is kind of preferences, and they're different types of kind of knowledge-driven stuff versus salience-driven, and so on and so on and so on. And then you can look at where they make contrasting and overlapping predictions. Yeah. And then you can kind of predict where people are going to look. So quite a few papers have done that, computational models to try to predict gaze location, either when looking at kind of static scenes or, this less well-developed kind of aerodynamic scenes. Okay. But yeah, so the key thing is that is all very well for explaining what I said, which is when you look at a slideshow of the touch of evil, yeah, that's all very good for predicting where people are going to look. Yeah. But it's this particular heat map here, yeah, on the boot of the car, which isn't explained by any of those things we've covered so far. Yeah. So to explain that burst of looking to the boot of the car, because we know from prior knowledge that there's a bomb in it. Yeah. To do that, we need to go at an added level of complexity. Yeah. So that's what they're talking about in this paper. The key unanswered question is how the key GIF is used for the current event model and how that in turn influences attention selection. Yeah, Tom?
I wondered, I mean, it makes total sense to me that this is driven by knowledge, but could it also be like the framing of the shot? Because it strikes me that like the boot of that car is quite carefully placed versus where the actors are. So it's sort of the lines of the shot and the fact that they're looking and facing that way would naturally lead your eye there, even if you had no. Oh, actually, is this covered for by the fact that they did just the shots in isolation as well as in the film?
Yeah.
That makes sense. Sorry.
No, good point though. I mean, all of this types of stuff they do, it's quite a different way of doing it. They do pick individual. There's another analysis that Tim's done on There Will Be Blood, which is another, what's he called? Where's not Anderson, Thomas Powell Anderson, another really good film, where he also says, look, you get gaze, but it's individual cherry-picked instances where you can see people's gaze, because the whole point is it's not being captured by our computational models. But yeah, the specific point you made about scene composition is, yeah, that's why they did that. Okay. So to do this, we need to go into another area of cognitive neuroscience, which is pioneered by Jeffrey Sachs, which is if you, and these are just, hey, Tom, these are the exact ones you're using, right? Or you started to use?
I started to use, but it's a contentious issue whether we continue to use them or not.
Okay, fine.
Yeah.
But basically, they're just videos of just people doing everyday stuff. Yeah. So this is someone having breakfast. These are 5 different people having breakfast. These are people doing exercise, people cleaning their bedrooms, and people grooming in their bathroom. And basically, what they do is they just try and get as neutral as possible, a kind of a perspective on what's going on. And then they do they do this on Amazon Turk, Tom? Do you remember? So what they do is they just get people to press a button to say when one event has ended and another one has started, yeah? And you get a very high degree of correspondence between when people are pressing the buttons, yeah? In the sense that there is such a thing as an objective, understanding of events, yeah? So obviously for breakfast, that is, I'm getting out the bowl. I mean, you've heard Tom say this lots of times, I'm pouring the cereal and so on and so on, yeah? Makes sense, okay. So the key thing, and it's all kind of fitted within this box and arrow model, and I kind of hate box and arrow models, but basically that they're talking about this, how do these different processes, yeah? So kind of visual saliency, can you see that thing? Sorry, it's really annoying me. How's visual saliency, does this say item specific features? I can't read that because I've got a thing on my thing. But how does visual saliency, these item-specific things, interact along with semantic knowledge? That's my prior knowledge, which has already been done. But then also these ideas of the current event model, yeah? And how does that interact with executive processes, yeah? And how do these things all combine to interactively look at kind of where we're looking during the course of the scene, yeah? And there really is definitely a question, when I'm listening, I can't remember who it was who said about audio books. When I'm listening to audio books with Rose, my 4-year-old, I'm very aware that to track a story on an audio book, you need to have a degree of working memory of what's just been happening, what's been happening, and then you need to be able to track back, yeah. So that's one of the areas, and then the other is your understanding, yeah, of what's happening. Yeah. So for Tom's paper, which you don't like, Tom, I don't know why you don't. You need to change, but I put in a bit for Tom's paper about imagine a baby's on your sling as you're making a bottle of water and making some milk for them. Yeah. So for you, it's because you understand what you're doing. Yeah. The way your brain is processing the information. I'm boiling the kettle. I'm getting the bottle out. I'm pouring some powder in. I'm pouring the milk in. You will process that in a very, very different way to a baby. Even if they are seeing the bottle in the same way, they won't know that the water is about to be poured into the bottle, but only after you put the milk in, and so on and so on. Yeah. So that's a different thing. That's not to do with kind of understanding of working memory, and it's not to do with salience, and it's not to do with my understanding of what a bottle is. Yeah. It's to do with this idea of kind of events and goals and these kind of higher order features. Yeah. So they're talking about this, how do all these things kind of interact? Yeah. So first, and this is stuff that Tom is going to be talking about tomorrow in the context of his movies, yeah? So we know that the likelihood of making a predictive eye movement decreases at event boundaries, yeah? So if you're doing one of these things and you're watching someone, yeah, who has just done something, yeah, so they've just finished doing their press-ups, yeah, and your likelihood that you will make a predictive eye movement. Tom, do we remember how that was defined? You don't happen to know how that was defined in that thing, because something that's not salience driven, one of the things that Tom's going to be talking about tomorrow is, it's very hard to be sure about anything other than was it predicted by the salience or not, yeah? So it may just be that kind of roundabout event boundaries, yeah, our eye movements become more salience driven, yeah, because we don't really have any other, higher order understanding of what might be guiding our eye movements other than what's salience driven, yeah.
I mean, this is a difficult one because like, there's a lot of other research that shows that even for like semantically meaningful, no, semantically meaningful is like the same word twice, isn't it? But like even for like higher order events, that they're still like predicted to some extent by low level features and movement. That like if you ask someone to like segment like goals on different levels, like the boundaries always correlate with movement and low level features. So what I'm going to say tomorrow is that actually no matter if like the boundary, like no matter what the boundary, whether it's in an intact or scrambled cartoon, it's still associated with like increased low level, like still increased with low level looking, like salience predicted looking, but probably more so when you don't have narrative structure, you don't have that other kind of semantic support. Because I think it's like,
that was Calliope's point earlier, that they did that. I mean, it's slightly different. Calliope was saying that, isn't it, that meaningful objects more likely to be salient, but you're saying, isn't it, that differences between events are marked by abrupt transitions and salience as well, so it's actually a different point, but it's very similar. Okay, but I don't exactly know how they made predictive eye movement, but it can be the same. You can get around it by the same one as they did here. So if you just show the same scene as a series of static frames, versus dynamic frames, then that gets around that to a degree. Obviously, you'd have to you'll be doing short clips, like chunking it up to keep the salience kind of transitions in the movement, but to destroy the kind of higher order event. So you can imagine doing some sort of a thing,
I think that Eisenberg, sorry. I think that Eisenberg paper, I don't think it was, like I've got it here somewhere, that in that paper they reference, I think it's actually ISC that they measured, but it's like that might be just a difference in how they're defining predictive, but it's that there's increased like gaze similarity around and they're saying around event boundaries. So they're saying it's predictable. Like in the subject, like what they didn't use inter-subject correlation, I think they used something similar, like that, people's like looking became more correlated with each other or more similar. Their movements became more like similar around event boundaries. I can look it up, but it was something like that. I don't think it was like actually anticipatory prediction that they were looking at in that Eisenberg paper.
Fine. Okay, I mean, I got that from the paper, but the review, but it could well be wrong. And then viewers fixate on actors' faces more at course boundaries, e.g. signifying the change from one goal to another, such as finishing laundry and sitting down to read. So again, that's something that Tom's going to be looking at in his analyses that he'll tell you about tomorrow. And pupil dilation and gaze similarity increases at event boundaries. So that's what you're just saying for the thing. This is partly because viewers shift into an ambient mode of processing as they lay the foundation of a current event model. Okay. And then just to get, I mean, there isn't a lot in this paper, beyond kind of stating the question. So I thought this was the other thing that is worth kind of thinking about. So Yuri Hasson's done some really lovely work on this type of thing. So basically, I can't remember exactly how. So one of the ways that he does this, and we talked about this before, is he shows that there's one paper that he did where they present an audio story, and they keep 19 out of 20 words. So you keep 19 out of 20 words the same, but in one version they change one word per 20 in such a way that it completely changes the meaning of the story. So instead of she was completely happy, she was completely devastated, and etc. And it changes the content of the story. And in another, they change one word in a way that doesn't change the meaning at all. And then they look at the inter-subject correlation, so the similarity in gaze in brain activity between people when they're listening to the story. And they basically find that disrupting the meaning, you get the low-level brain areas. They have very similar activity between the two versions of the meaning disrupted story. But the higher order brain areas, they show more dissimilarity. So they're more affected by the kind of higher order meaning. So they talk about this as in terms of a kind of hierarchy from low level features that are processed over short time frames, like phonemes, kind of words and sentences, through to higher level features that are processed over longer timeframes. Yeah, and quite a lot of work has been done looking at kind of the same types of ideas in terms of visual hierarchies, and in terms of visual hierarchies are expressed in the brain. Yeah, so that is also something that's not talked about in this paper, and this figures from a Yuri Hasson, a recent review he did in the Journal of Neuroscience just on this. But obviously, this is something that's very related and very relevant. Yeah. So basically, I mean, I don't, honestly, I didn't, I think it's a nice paper, but I didn't love it because basically, kind of what they do for most of the paper, but haven't characterized this in a lot of detail, is they kind of say that there are 3 areas that must be important, yeah, when we're using our understanding of events as they unfold to influence our gaze behavior. Yeah, but the first of them is laying the foundation. Yeah, so you have an ambient to focal shift as event models transition from laying the foundation to mapping incoming information. Yeah, but I don't know how they'd really do that, given that, as Tom was just saying, you actually get more into subject correlation in gaze behavior around the start of an event. Yeah, so I'm more kind of salience driven around the start of the event. Yeah, and again, there's no real evidence that working memory contents kind of are involved in laying the foundation and mapping it. Yeah, it seems to me intuitively the case that you must be using your working memory to track something, but I don't know how you prove that in a way that's actually falsifiable. Yeah. And then they talk about these visual search, like attention deployments during mapping or shifting to create a new event model. Yeah. So I don't know. So it just seems to me all kind of intuitively likely that these are all kind of things that are intermingled in this kind of very complex way. What you really need to do is to do some build a computational model to try to predict these things, and then you'll get a really good idea for how these things interact. But nobody's done that because it's very complicated. Yeah.
Sorry, Sam, could I just quickly say that I didn't mean to say that it was focal around the start of an event. It's increasing similarity towards the end of the event, so that's close to what they say in 1.
Oh, okay.
Is that it actually becomes more like synchronized, and it like becomes more focused as the group becomes more clustered, as their gaze becomes more clustered, like on the on the event as it gets closer to the event boundary.
But how does that fit with the idea it's more salience driven?
Because like if we think about it, like event boundary usually corresponding to like goal completion. Goal completion usually represents something that's quite perceptually abrupt, like in terms of there being like a sharper that usually it's like goal completions are correspond to like abrupt changes in movement. So from going to not going, basically, it's quite.
I kind of see. Yeah. Okay. Yeah. Okay. And then the other thing, but yeah. So basically, I don't know. They talk a lot about these kind of different things that all must be involved, if you think about it hard enough, in controlling where we look when we're building our things. Yeah. But really, you need kind of. They've done lots of dynamic models for looking at kind of how long you look at a particular space, how long you look in a particular kind of location. But they really need something like that, and they haven't done that yet. It's very complicated. But the other thing that I put in here is just this, another, not from this paper, but from another group. And again, we talked about this before, but just to remind you, because it's really beautiful, elegant. This is some of the best neuroscience I think that's happened recently. Again, Yuri Hasson's group, and they actually do what's it called, where they actually stick a live electrode into the brain for someone while they're having open brain surgery for epilepsy. And you get a very high resolution but you get very good temporal resolution as well in where you're recording from. So they actually record from kind of neurons, individual groups of neurons in the hippocampus. Yeah. The first time they watch an event, a movie with discrete events through, yeah, compared to the second time, then they get more retrieval of more kind of information going to and from the hippocampus shortly after at the start of the new event, yeah, which they take as this, we're dynamically shifting information while we're viewing an event into our hippocampus as we go, based on our understanding, yeah, which is really nice, kind of really elegant kind of way of kind of thinking about some of these factors, yeah. But then this is back to kind of Calliope's point earlier. Yeah. So this is trying to say which of these are the most important, of the stuff that they're talking about. And they say, if you put these two, as we say, a lot of the time they overlap. But if you try and put them in competition, task-driven top-down influences seem to be at the top of the hierarchy, then visual salience, then knowledge-driven top-down influences. So those are the three that they talk about early on. But yeah, and then these kind of schemas and event models seem to be the least strong when you put them in competition. But I don't know, it's hard to think. Okay, so that's all from the paper. Yeah, Tom?
I'm really sorry. This is kind of falling out of my head a little bit, but the difference between like the task-driven and knowledge-driven, is the task-driven like making a tea and you know where to look next because it's the next in the procedure, and knowledge is like look for chimneys.
So when they talk about it at the beginning, this is task-driven, and then knowledge-driven are these meaning maps, So don't ignore that because it is a bit confusing because that Eckstein is more task-driven in that sense. So ignore that. But just imagine that this is knowledge-driven in the sense of I'm just showing loads and loads and loads of pictures to people, and I'm looking at where they look and I'm trying to predict where they're going to look.
So like if you're making a cup of tea and you have like the task, and the task is to get a teaspoon, but you also have like the knowledge, if you're making a cup of tea, I don't know, in a new kitchen, then you also have like the knowledge of where the teaspoons are going to be. So you then therefore would have the interaction of both the schema.
Good point. So I guess so that would be I guess that would be, well, semantic memory comes through in a couple of points, doesn't it? Because on the one hand, it's semantic memory that I'm making a cup of tea, therefore I need to get a teaspoon, but there's other type of semantic memory. I'm not sure that it was semantic memory actually, which is where the teaspoons are, and then the episodic memory is I'm in the middle of making a cup of tea. But you're right, they do interact in a context. But that's the way that they define them, Tom. But okay, good. All right, so that's all on the paper. I mean, let's just quickly whiz through, and I've just put very quick things. So Tom's just writing this paper saying, how do babies learn to construct kind of events in the same way? One is this point that, as we've already been saying, if you habituate them to events, so you see a kind of an event that's happening over and over again, and then if you pause the video in the middle of an event compared to at the end of an event, they look for longer when you pause it in the middle of the event, but that doesn't necessarily tell us anything that interesting, because as Tom Northrup was saying earlier, the low-level features tend to cluster anyway around the edges of these events. So when I've just poured the water into the thing and then I've put the kettle down, you get less movement for a second until I go on to do something else. So it's quite hard to be sure. There probably is this idea of there's a lot of evidence about this idea of statistical learning. So much better developed in the context of word learning. So it's the same thing that the word segmentation problem in word learning, how the continuous acoustic pattern of speech is continuous. So how do I learn to chunk words into discrete chunks? And it's probably that we know that like particular clusters of phonemes are more likely to occur around word boundaries. So I learn to parse the continuous acoustic stream of speech into discrete words, by saying, okay, I've heard this chunk of phonemes, and I know from experience that this chunk of phonemes is more likely to indicate the end of a word. Therefore, I'm guessing that there's an end of a word there. So it could be something similar in terms of this, that we're sensitive to these statistical regularities. Obviously, it's a much noisier thing in terms of kind of vision, but there's some idea of that possible. Tom, anything you want to add to that?
I mean, sorry, someone mute there. I'll get my feedback. Can you mute your thing, please? Tom, can you mute? Sorry. I was just saying that basically, what was I saying? There's like we've got like this experimental paradigms that show that. I mean that it's like sufficient for like the infants being able to make chunks, but it's actually really hard to like extrapolate that to, you know, like how we segment continuous reality as adults, because in adults like we can just yeah, like basically we know that it's like sufficient for children being able to form cohesive units, but we don't know that's actually how they do it. It's quite hard to actually measure that that's how they would segment continuous experience. And it's really hard to study how infants segment continuous experience without doing it as some kind of violation of expectation or a habituation paradigm, because, you know, we don't have the benefit of like them like being able to instruct them to like press a space bar or something every time they feel one meaningful unit ends and another one begins. Yeah, otherwise I don't have much to add.
Yeah. The other point, which is another interesting topic that we could talk about for ages, is the relationship of this, whether you use similar stuff to look at kind of like interpersonal interactions in the same way, like whether you know, in that then goes into lots of interesting stuff about, you know, the regularities that cluster together in interpersonal relationships, but let's not go into that. So, and then the other thing is, the other bit that we talk about in Tom's paper is, what about higher order object categories? Yeah, so that's this idea of knowledge-based segmentation, which is this the one being looked at here. Yeah. So how do we learn to work out, you know, what particular objects are meaningful? Yeah, you know, on their own. Yeah. Independent of salience, although again, you know, it very overlaps with salience, but it's just, it doesn't always overlap with salience. Yeah. So how do we learn to, you know, work out what particular object categories are, and that type of stuff. Tom, anything we want to say about that?
Not that I can think of right now.
No. Okay, that's the other thing. And then the other thing, obviously, is, you know, the area that gets some people, you know, very excited is this idea of, okay, but there's also something in events. Yeah, there's something beyond that. There's something cognitive. Yeah. So how do we kind of understand, develop this awareness of goal related? Yeah. So how do I track that I'm watching someone and they're making a cup of tea and they have a goal? Yeah. So people like Vicky Southgate, when I was doing my PhD, are doing lots of kind of experiments looking at that. You know, either I'm reaching or I'm reaching towards something. Yeah. And how does the fact that I'm reaching towards something affect how babies' brains learn to process that? Yeah. So are we tracking, you know, how do we develop that ability to attribute goals to people? Yeah. Yeah. Tom, what do we want to say about that? So it's quite hard to get from the statistical learning account to, you know, the goal attribution, right?
Very, very difficult to get to that, because then it's also just like this huge argument about like how, like, if we do actually represent like goals as these like these like rich cognitive like representations in mind, or whether goals are something that more like are just scaffolded by the environment that we do. Like, you know, yeah, basically there's an argument about like to what extent we actually have goal representations, and to what extent it's just like a response or like a reaction to the environment, because it's like quite hard to actually pin that in mind. Yeah, I don't know.
Yeah, so that's what people like Vicky Southgate have tried to look at by doing that. You know, I'm either reaching towards something or I'm doing an identical movement, but it doesn't have a goal. Yeah, to look at, you know, does this get like sensory motor alpha? So she does like parietal sensory motor alpha music desynchronization, but, you know, it is very, very hard with those very, very controlled non-ecological experiments to be sure what's what. But yeah, it's quite tricky. Yeah. And then, yeah, sorry, this should have gone on a different slide, but this was just a paper that actually I was a reviewer on this, and, you know, I was saying reject it, but so now I'm a bit cross with myself because I'm now citing it. But I thought it was very kind of dodgy the way they'd done it. It's a very, very small N doing a very, very, very sophisticated fMRI analysis, but there were lots of bits of the thing that made me think it was very unlikely to replicate when you looked at it in a lot of detail, which I did when I was reviewing it. But basically, the takeaway was infants represented relatively long events. So it was doing these same types of analyses as Yuri Hasson's done here, yeah, looking at these hierarchies of kind of goal representation, hierarchies of kind of event processing from kind of higher order goals through to kind of longer temporal windows, yeah, and trying to apply some of these to look at babies' brains when they're watching movies, yeah. And basically the takeaway was that infants represented relatively long events and event processing became more hierarchical over infant age, yeah, both of which sound like quite sensible conclusions. But as I say, I think the specifics of the thing wouldn't necessarily replicate if you did that same experiment again. So anyway, so that's this kind of relatively unknown area, which is, you know, how do babies kind of, how do these processes, how are they different in babies? But as I say, really in adults, you know, we're at the stage where, you know, we can give you data that kind of the current models that we have aren't enough. Yeah, and it's intuitively obvious that the current models that we have aren't enough, but we can't yet, you know, have, and we can talk about some of the things that we know must be involved in this processes, yeah, but we can't yet come up with a detailed mechanistic account of, you know, how exactly these processes are kind of influencing gaze behavior. It's a, you know, really easy area to ask questions about, but very hard area to get conclusive answers on, yeah. And that's obviously in adults, so we're really much further off than being able to understand how we develop the ability to process these kind of complex visual kind of structures. Yeah. Okay.
I have another question.
Yeah.
Hi, sorry. So at least for attachment behaviors, what I know is that they tend to be activated or deactivated by different stimuli, but mostly those that are coming from human-like traits. So I didn't get if this paper took into account what does the task or the event involves. Like, are there people involved on the event? Like, what's happening? What are they seeing? Or
yeah, sorry, say again the link to attachment.
yeah, so in attachment behaviors from babies are usually activated by different stimuli, and it's more frequent that these stimuli involve human-like traits, so people most of the times, and that's more salient, I guess, in the terms of this paper. So I was wondering, what does the task or the event that they're referring to refers to? Is this a task or an event that involves people, or is it just something that involves a room? Or
so Tom, help me out on this if you can. That I know that I think, you know, since the definition of event is very closely related to the definition of a goal, yeah. So in this bit here, so these are very much, you know, the way that they're doing these types of events is, you know, I finished plucking my eyebrows, yeah, and then I get a new goal, which is to squeeze my zits, yeah. So that, you know, has to be the only way we're defining an event is by a change in the goal of the person. So you have to do it with a goal. But they have, I know that there are some experiments I saw where you know, you have some animated shapes moving around the screen, and you infer that the you know, a triangle is trying to pop the ball, yeah, from the fact that it's chasing it around and going through, and you infer that the ball is trying to get out of the way of the triangle just from looking at their movements. So they have tried to do it like that. Gergi Sibra's lab they've just moved to Vienna. They've done some experiments looking at that, but I don't know very much. Tom, can you add to anything on that?
I don't know about Gergi Sibra's lab, but I know that, yeah, there's some of like the event stuff that's been done with like trying to like take you know, it being a human process going on, doing the shapes chasing each other around. It shows, I think, pretty much I think they showed that it was like a similar thing where yeah, like especially at lower, finer grains of segmentation, it was like more related to movement. At a higher order, it was still related to movement, but like less correlated with movement. They still had like hierarchical segmentation of the shapes thing. But it's like interesting. I think it doesn't, like, we think about it often in terms of goals and like how goals fit that hierarchical event structure, but I'm not necessarily sure how much it is specific to like it definitely involves goals, but you know, I think that for instance, if you think about, I don't know, maybe I'm just confusing things a bit here, but thinking about like natural phenomena as well, like science processes, you might like hierarchically break that down into specific events. But I'm not sure how much that's the same. Like most of the time they do the research, it's based on humans doing stuff like and act as goals, and they define events like saying mostly by the time by asking people to mark when they feel one meaningful unit ends and another one begins. And most of that time that corresponds to like some kind of goal completion. But it's like it's uncertain to what extent like this is specific to humans' goal-directed behavior, and to what extent it's like just like a natural way that we process like multi-time scale information, which I think it probably like we do probably do like process things that aren't human like hierarchically. But I think yeah, this like event stuff is probably like the way it's just phrased is it's always going to kind of lend itself just to being related to goals. And then even we're talking about the shapes example before, we're applying like human agency to thinking about that, or like the triangle chased around the square. We're talking about the triangle and the square as if they were like agents. So it's hard to pull apart. Sorry if I didn't answer your question there and just blabbed on. I wasn't sure.
I think that's fair enough. Yeah.
Because what I was thinking is that maybe that makes some sense in the example that I don't remember who brought it up with like the bottle, like when you hold the baby and you're preparing some milk, then the baby does not know what is being done there. So that's not salient to the baby, but maybe the event per se is salient just because another human being is involved. So maybe that's why attention is there. Or maybe they don't know exactly what's the procedure or the sequence of like warming up milk. But since my mom is doing that, like,
Yeah,
relevant to me.
I guess it's going to be salient, like, but it's still whether like that's probably not the question that we're really interested in that. So like I think a lot of the ways that the parent will move, like there's a lot of reasons why like humans are like, you know, children are very sensitive to like biological motion from very early on for whatever reason, and like humans and faces for whatever reason. But I suppose it's like like that, considering all of that, do they perceive this like hierarchically organized goal structure in their behavior, or is the salience just like an unbroken blur, like a continuous blur like of information? Because yeah, it could still be salient, but is it like it's more about the structure of the salience rather than like how overall salient that thing might be? Yeah, sorry.
No, yeah, but I take your point, but there's a lot, yeah, there's overlap, as you're saying, but yeah. Right, okay, we should wrap up. Oh, yeah, oh no. Really? What? Thank you very much to those of you who are applauding. Marta can't be bothered to lift her fingers to clap. She can do a clap and make you. I'm not sure that's. All right, lovely to see everyone. Katie, do you want to say a line with your meeting now? Yeah. All right then.
Yeah.
Thanks everyone else. So bye.